Hi, in this video, we want to take a look at topic modeling with R. All right, so for this, we want to tackle topic modeling with two methods, either correlated version or the latent Dirichlet allocation method. All right, so both of these are good choices when you want to do topic modeling. For this particular example, what we're going to do, we're going to look at correlated topics for the first one, and then latent Dirichlet for the second one. All right, so latent Dirichlet, the reason why that one is very advantageous, why that we like this a lot, is first and foremost, it computes pretty fast compared to the correlated topic models, but also we have a lot of like mathematical theory holding that up, because when it comes to probability vectors, we really only have one major distribution from the focus of statistics to be able to tackle things, and that is the Dirichlet distribution. How we get that is that we take gamma random variables with the same the same scale, but shape can be different, and then we have a vector of gamma random variables, and then we rescale the vector to be a probability vector, and there we get a very nice probability vector. And that gives us theory to be able to handle things from a statistics point of view if we want to go deeper on topic modeling. All right, so what we're going to do, we're going to take tweets from presidential candidates during the 2020 election. All right, so President Trump had the Republican nomination, but at the point that I pulled these tweets, there were plenty of Democrat candidates trying to be nominated in the primary. And so what we're going to do, we're going to throw them all into one big group, and we're going to just take a look at what's going on. All right, so how I'm going to tackle this, you notice I have a complete collection of data sets to work in, and I need to load these. Now, if I will go through and I load each one of these one at a time, I'm going to have a much longer code, and I'm going to have objects kind of floating around in my workspace. I can do this cleaner and faster and easier by doing this all in one shot and storing it into a list using the lapply function. All right, so what I do is I say, this is where I want to set up my working directory. I've got everything in the input folder, and here are the names of the tweets. Now with lapply, what I do is I specify the object I want to work over. So in R, usually we want to avoid for loops. If I can, instead of a for loop, I want to use lapply, sapply, some version of apply. And so here, what we're going to do, I'm going to make a special function. I'm going to make a read CSV specialized function to take an entry from this vector, read it in, put everything in as a character, and then trim it down to just the name of the author and the text of the tweet. And then after I do that, well, I'm going to want to name things so I can reference the list objects down the road as I work through. So what I'm going to do is I'm going to go through, I'm going to remove the information from the file path that I don't want. So notice, so when I remove this, the input will be gone and the .csv will be gone, and I'll just have the author's name left. It'll work out nicely. All right, so now I'm going to do data prep. Whenever you do any text analytics project, data prep is absolutely critical. If you have poor data prep, you will get poor models. All right, so for this, what I'm going to do, I'm going to put everything into one data set and put them all together. So how I'm going to do that, see, I've got a list of data sets with the same columns going on and the same data types in those columns. So the column names are the same in the same positions every single time, and the type of data for each of those columns in every one of the data sets is the same. So I can go through and I can use dplyR's bind rows to put it all into one data frame. Now, this output will give me a tibble. I don't like tibbles. I'm old. I learned R before tibbles were a thing. So I want to work with a data frame. All right, now let's go ahead and start cleaning some stuff up. Now, tweets are going to have a lot of junk and crap that we don't want, and a lot of specialized text in them that I can't take advantage of, or I'll need a lot of data to be able to use. So what I'm going to do in the fastest, easiest, laziest way I possibly can, I'm going to clean this up. All right, so here, that / capital W says find everything that is a non-printable character. And then I'm using gsub to find the non-printable characters and then replace them with just a space. So if I have special characters floating around in there, I'm just getting rid of it. So this is a much faster way to clean out a lot of things. One problem with this is that I'll be breaking up like websites, I'll be breaking up email addresses, things like that will be gotten rid of very quickly. All right, now after I'm done with that, I want to go through, I chose for this project to get rid of digits. And there's a couple different ways. There's 3 ways to go about it with this gsub. You could do 0 to 9 inside the brackets like I did here. You could do / D, that's also a way, or I could use the digits, a regular expression also. And then I replace each number with a space. Now here I'm getting rid of punctuation with a regular expression. And now I look through and I noticed that there were, after doing all this cleanup, as I checked my output, I noticed that I had 1 and 2 character words, tokens in the data sets. Well, 2 letters, 1 letter, it's not going to be informative. So I'm going to go ahead and just get rid of all of those. And so what I did here is I'm saying this period is a special character in R for text analytics. This is almost any character. It basically says find any character that is length 1 or length 2, and I have a space in front of it and a space after it. So if I had, let's say, the word I, space, then what would happen is because of this 1, it would get rid of it. If I had the word me, which was space, ME, then space, this would also get rid of it. So what I'm saying here, if I see 2 characters, or I see 1 character, so 1 or 2 characters with a space in front of it and a space behind it, just get rid of it. And now, I've introduced a lot of empty spaces at this point. I'm going to go ahead and go in, and when I have 2, 3, 4, 2 or more consecutive spaces, I'm going to just replace them all down to just 1 space. Now I'm going to get rid of stop words. I recommend that you go, and generally I think you should be aggressive about removing stop words. And so here I'm doing it multiple times. I am using the stop words EN list, stop words smart list, and QDAP dictionaries top 200 words. And so all of these have overlapping words, but there are a few words in each of them that aren't in the others. I'm being pretty aggressive about removing stop words. Now, at this point, when I was working through, preparing for the video, I took a look at what I had, and I noticed that these international characters were in there, and I said, hey, just go ahead and replace them with, the American English version. And then here, I'm just going in and double checking to make sure I don't have any of those 1 or 2 character words left. And I'm just making sure that there's no consecutive spaces, just to keep things cleaner. Now, stemming words, what I do here is I take words that have the same root and I convert them all to the same root. That way I have a consistent form. If I had jumping, jumped, jumps, jumper, those are all converted over to the word jump. Okay, so now something that is important, that if you're going to do this, if you're going to stem your document and you're going to show people who are not data scientists your output, you need to do completion on the next step. For this video, I'm not doing completion because it just takes a little bit of time. I don't feel like wasting time on it. All right, now, when I was working through this, I took a look at what did I have in my data. Let's try to see what's going on. Let's start cleaning it up. Well, here are things from Twitter that, internet addresses and things specific to Twitter that are not informative to what's going on, because they're all tweets. So it doesn't help. So I just want to get rid of them altogether. Now we're talking about the presidential election. And so really, if you look at how they speak, when they say America or American, really political candidates are saying the same thing. So I decided to go ahead and convert them over. So every time I see American, I convert it over to just America. And that A appears frequently in the data set, so I just went ahead and got rid of that. Also, I converted real Donald Trump and Donald to just Trump. And I converted Trumpa to Trump. I could, with this or statement, I could have put Trumpa up here, but I did not. And then also, when you look at the language of the presidential candidates, when they say president, presidential, presidency, they're saying really the same thing. So I want to convert that over to the same root word. All right, so I looked through here and I looked at words that for this context don't mean anything. So frequently the word today, fight, country, president, America, and country came up. These are such frequent words that these really don't mean anything in this context. You know, saying that, oh, today we're going to do blah, blah, blah. You know, that, you know, when a politician speaks, that's not meaningful. Fight, they're all just saying fight. You know, then country and America, you know, given the context, they're just saying, they say these words over and over and over. Of course, they're talking about the United States. All right, so after I did that, I went ahead and I wanted to go through and remove all of the tweets that at this point, after all the cleanup, had 0 characters. There weren't very many that had 0 characters at this point, but I wanted to clean them out. And so here, how I did that, once again, I got rid of white space, and by trimming out any endpoint white space, if I had 0 characters in a tweet, then I want to get rid of it. All right, now, remember that I stacked the original data sets on top of each other using bind rows from the dplyr package. Now that I've done this, I want to break them up again so I can proceed. And so what I'm going to do is I'm going to take that big data frame of all the tweets, and I'm going to break them up by the author's name. Something that's nice about this technique is that I don't have to manually name things in the list like I did previously when I loaded the data in. All right, so now let's go ahead and create our document term matrices. All right, the first thing I have to do before I can do that is I need to convert the text to corpi. All right, so for each candidate, I'm going to have a different corpus, and I'm going to convert each corpus to a document term matrix. There's different types of corpus in the TM package. The volatile one is the one that's more set up for editing, and that's usually the one we use. Now, I've got text in the form of a vector. So one thing I have to do, I have to convert the text using the vector source, and then I pass that to the vector source or vector corpus function to create my corpi. And notice that I'm using the lapply function to do this fast over over every single sub data set I have. Then what I'm going to do for each individual candidate's corpus, I'm going to convert it to a document term matrix using the document term matrix function and lapply. So this iteratively goes over every single corpus and converts it to a document term matrix. Now let's take a look at our output. All right, so we can see that, so it doesn't give the names, but they're in alphabetical order because I sorted them. Alphabetical order by that file path vector, that is. And so we can see that the first one, which was Amy, nice that she put that in there, had, you know, after the cleanup, of about 3,200 tweets, and over 9,500 individual terms after we cleaned up. The sparsity, it's nearly 100%. The maximum term length is 27. And we can get these individual pieces of information for each candidate if we choose. This one's for Bernie. And we can dig into this using the inspect function. Something that's important about this is that when I put things into a document term matrix in the TM package, to actually look at what's going on, I need to use the inspect function. I can't call the document term matrix the same way as I call a regular matrix in R. We must use the inspect function. All right, so here we can look at each individual candidate's document term matrix. This is the first few rows. This is the first few columns. Truncated down just so that we can get a feel for what it looks like. All right, so now something I want to do, I want to remove sparse terms. So imagine a case where a word is used in one tweet, one time. That's not going to be informative because I don't have enough data on it. And so I need to get rid of such words. So playing around, I conclude that 0.995 is the sparsity parameter that works for this individual project. Usually I use a lower number. So this is saying if it's over 99.5% zeros in the document term matrix, that column is completely removed. And so when I do that, you'll notice that I lose terms off of each of these. Remember that there were 3,200 from Amy's tweets previously. Now it's down to about 550. That's a huge reduction. And so that tells me that there were a lot of sparse terms in that document term matrix. That means that even after stemming, there are words that were appearing just one or two times in all of the tweets. And those words are not going to be informative because I just don't have enough data. And so here you can see that it's less than 500, less than 500, just under 550, about 500, and so on. We can keep on scrolling through this. All right, so now I've gone through and I've removed sparse terms. So imagine a situation that a tweet only had sparse terms in it after I did all the cleanup. Well, then the entire row is going to be all zeros. Well, all zero row is not going to be informative for my project. So once again, I want to kick that out. And so I'm going to use row sums to go through and get rid of stuff. So here's what I did. For each document term matrix, I compute the row sum. Then I only keep the rows that have one or more terms in them. And if I wanted to be more aggressive, I could change that to increase it to 1, 2, 3, so that only tweets with multiple words would be available. And since I'm getting rid of rows, I went ahead and relabeled the row names. All right, so now let's go ahead and just take a quick look at the terms that each candidate used. So I'm taking my document term matrix and I'm dropping it into the document term matrix 2 Latent Dirichlet allocation format function. And then I'm just grabbing the vocab. And here's just the head, just so that we just see the first few. And you'll notice I'm using the lapply function to do this iteratively over the entire list. And so we can just see what are the first words. Now, this isn't in terms of frequency, this is in terms of alphabetical. All right, so now let's run correlated topic models. All right, so to do this, in the topic models package, we use the CTM function. and we have to specify how many topics we want. I feel like a larger number would be better, but to keep the printout in this video from being too much, I'm limiting it down to 5. Honestly, I think maybe 10 might have been about the right number. I just played around with it. When I saw the output was going to be like wider than what I wanted to keep in the video, I just put it down to 5, just so that you, the audience, can be able to see what's going on. All right, so here, once again with lapply, I'm able to get very cleanly a list of all the models in one spot, so that I can run functions using lapply again to clean things up. So now let's take a look at the perplexity of each of these models for the correlated topic models. And so I'm using the perplexity function in topic models, and I'm going to do this using sapply this time. Simple, so it's lapply, but simplify apply. And then I'm going to sort it. And so we can see that Tulsi and Amy had the most perplexing correlated topic models, while Donald Trump and Bernie had the least, and then Joe Biden. Now we can also check model quality using log likelihood. And so here we can just see what's going on. We can see that President Trump, it looks like his model is fitting the distribution assumption model the best. We can get the terms for each of these. So here, I'm just going to take the top 5 terms from each of the topic models. And so we can just look through here and just see pass, plan, bill, healthcare. So Amy was talking about passing a healthcare bill. Then topic 2 is Trump, Iowa elect country Senate. Then I guess this one's probably like trying to recruit people to help. Win, state, vote, bring, and stand. Stand's probably another stop word I could have removed. Community, work, team, and probably wealth and talk. So probably talking about community there. Bernie Sanders, workers, climate, corporate, pay, greed. It's probably workers' pay. Bernie Sanders, politics, state, vote. So he's basically saying vote for me. Bernie Sanders, I probably should convert this to Bernie. Movement, justice, build, debt. Trump, align, care, health, Medicare. So he's probably criticizing Trump's healthcare policies. Work, stand, join, class, families. And so we can see each of these. One thing I find interesting is how impeach comes up with President Trump so frequently. Shift, Pelosi, report, news, Democrats. And we can, go through, analyze each of these. Now, something that we'll definitely want to know is when I look at a word, what's the likelihood that it's, or how much does it connect to a particular topic? And to get that, I need the posterior function, and I grab the terms. So here, the posterior function has topics and terms. We want the terms on this one. And to format it, I took the transpose and just grabbed the head. So we're only getting the first 6 rows for each of these. And so here, this gives a numeric evaluation of how much each word connects to each topic. And so if I want to say, hey, when I talk about action, we can see that action is going for this particular model is the most connected to the first topic because it's the largest. Now we can also get the topics out. So here, similar to what we had above. So above told us how much does each word connect to a topic. This next part, what we want to do, we want to classify each tweet as which topic does it look like it belongs to. And so if I look here, I can see that it looks pretty strong that tweet 4 from Amy is in topic 1. Now, you'll notice that a lot of these don't really have large values. Like this one here, we can be pretty confident that the second tweet is not in topic 1, but we have relatively even throughout for the rest. When I see even throughout, that's a sign I don't have a good enough model. One thing I would want to consider is more topics to be able to work on this. Playing around, I felt like a larger number would have given a better result. The correlated topic models takes a bit of time to compute though, so I didn't want to do that. And we have another function for getting the topics, but I felt like the posterior function gives better functionality, so I didn't include it here. Now for latent Dirichlet allocation models, so here we're making the assumption that we have a probability vector under the hood connecting to the classification of each topic. All right, so here I'm going to use the LDA function. Once again, I'm going with 5 topics. I feel like more is actually the right number here, but for the output of this video, I kept it down to 5. And we can look at the perplexity just like we did before. So we can see that Trump and Bernie have the lowest perplexity. We can do log-like. We get similar results as before, in a little bit different order. Once again, we can look at the terms for each of these. I find it interesting how much Trump comes up in other people's tweets. And we can also use posterior again on LDA to get the terms for the classification. And so, so we can be pretty confident that Abigail is not in topic 3 or 4. So I guess it would be most likely topic 5 for Amy. And if I want the classification of each tweet, I can use posterior again, and I grab the topics out. Now here you'll notice that the LDA gives pretty even across the board for the candidates. So I look at this and I conclude that my LDA models probably are not good models. I probably don't want to use these models at all. I feel like just playing around with it, that more topics are needed to be able to get a better modeling going. Yeah, you can see that's 0.2 across the board. This is just meaningless gunk. All right, well, that's all I've got for you. Take care and goodbye.